Greetings, this is Yash from Aditya Academy and I welcome you to the introductory lecture of 9th standard, 9th SSC board. Yes, we are talking about the Maharashtra board. Let us get started without any further ado. In this introductory lecture, I will explain you about the field of science, the subject science, how it's segregated and how it's going to be from the next year onwards. But before we move on to that, let's understand what is science. Okay, so when you come across this word called science, okay, a lot of us are not aware of these three facts. Okay, there are three subdivisions of science. Okay, the first one is called physics. The second one, namely known to be as biology, and the third one absolutely is chemistry. Now, if you go to understand each one of them in depth, they are huge in terms of curriculum. But just because this is an introductory lecture, we will be just looking at what they are in general. Talking about physics first. Now, physics is everything that deals with this physical world. Every natural phenomenon around you. Suppose I hold this pen, I drop it down, there's an object which moves from one position to another. All of that comes under the field of physics, okay, which derives from a physical world. Everything around you. So you will be studying about forces, about motion, okay, and everything that's around. Okay, that is what we're going to look into. Every phenomenon that is affected, matter, solid, liquid, gases, their conversion, okay, you can see it happening. That's physics. Now, physics and chemistry are quite related. So let me discuss chemistry to you. Chemistry is about understanding atoms. You see, every matter around us is made of constituent atoms. Atom is the smallest indivisible particle of matter. Yes, we are made up of atom. Everything in this universe are made up of atom. However, their composition is different. And that is what we study in chemistry. We study about atoms, we study about reactions, we study about different matter and whatnot. And lastly, we come to biology. Yes, biology discusses everything about the living organisms, whether it be plant-based, that is we call botany. Studying about plants is called botany, whereas studying about animals and mammals basically would be known to be as zoology. So when you study about living organisms, okay, you study about living organisms, you study about cells and lots of it. Okay, if you look at your entire syllabus, yeah, it's been not being mentioned over there. What are physics, what is chemistry, what is biology? But if we look into it into much deeper context, you can see it's mentioned over there. They have the subject names, and based on that, we can understand which is physics, which is chemistry, which is biology. The very first chapter is the physics chapter, and that is what we are going to start with today. Laws of motion. Okay. Beginning with your very first chapter, laws of motion. Yes, it has a beautiful heading. Okay, you like the sound of it? सुनने में अच्छा लगता है, laws of motion. But let's understand and let's put emphasis on understanding what basically, to understand the laws of motion, first you need to understand what in general is motion. You see, motion is something which has to be defined in very easy words. When I ask students or when I ask anyone to explain me what motion, when I say that suppose there's anything, for instance, let's suppose we say an object. There's an object, okay, I draw an object right in front of you all guys, okay, this is an object, okay, I call it an object, okay. If this object is in motion, that means it displaces itself moving from point A all the way to point B right over here. So this object has moved from point A to B, okay. How will you put it into words? How will you tell someone that this is how an object is in motion? People say it moves. Moves is same as you calling it in motion. I would say the simple word to understand this is saying an object change its position. That's absolutely right. So when I use the word motion, I have to mention right over there that motion is when an object changes its position. In other words, I could also say that when an object displaces. Now, displacement is something that we're going to study. Okay, displacement is something that we're going to study now, but basically this is the idea of motion. And whenever I look at an object, suppose I am walking on the road, you see me in motion, that means you have seen me changing my position from one place to another. I have changed my location. I'm not there at one spot. First I was at point A maybe, then I moved at B. The only reason you know I possessed motion or I was in motion is simply because you know I changed my position. And whenever an object changes its position, it is said to be in motion. Simple. This chapter basically starts with the simple idea of understanding distance and displacement. Now, displacement is something that I just said. However, it will make no sense to you because you have never understood or never, not understood, but maybe you have never studied about what displacement is. Let's take an example to understand distance and displacement. Okay, let's take this simple example. Okay, suppose you are going a path, you are taking a path, okay, and you start at point A. You start from here, okay, and your entire path ends up at point B, right over here. But the only problem right over here is when you're going from A to B, there are obstacles in your road. That means, suppose there's a mountain over here, there's another mountain over here, okay, and the problem is you cannot travel straight. There's no way that you can travel straight. There's no way that you can go through these mountains from point A to point B. That's not possible. Hence, you're going to take a way like this. You're going to take another route. You're going to travel like this approximately, right? Okay. Just to understand this, okay. So, suppose this pink line drawn over here, okay. I say it's the distance. I say it's the distance. It's the distance. And there's a straight line that I'm going to draw, which is going to be a dotted line, which you cannot take right now unless and until we make a tunnel. But there are no tunnels in between these mountains. So there's a straight dotted line which is going from A right up to point B. Can you see that? Yeah, fantastic. Now, suppose I call this yellow line, dotted line, to be displacement. You see, this itself is the simplest way of understanding the difference between distance and displacement. Understand it this way. Distance is the mehnat that you do. In Hindi, we call it mehnat, also known as your hard work that you put in. In physics, okay, whenever there is something, okay, which does not have a direction. You see, distance, whenever you're measuring distance, there is no direction. The simple reason is because you do not ask what direction are you traveling or covering the distances. The definition of distance basically says, okay, the magnitude covered by an object. When I say magnitude, that basically means the amount of distance that I'm covering in meters, suppose. Okay, so suppose this guy takes this entire pink path, and this pink path is around 6 kilometers, supposedly I say. So that is that guy's mehnat, the hard work that he is putting in. It does not matter what turns he take, what direction he goes. It has no direction. That is why distance is known to be a scalar quantity. In physics, scalar quantities are quantities which do not have direction. I'll explain you what direction is all about as well. Okay, but just please understand this. Scalar means only magnitude. Only magnitude, no direction. No direction. Now let's understand what is displacement. Displacement, on the other hand, denoted by a yellow dotted line right over here, okay, is something different. Displacement is known to be the shortest path between the initial and the final position. Now you see, displacement and distance are quite the opposite. Distance is basically measured based on what path you are taking. Displacement doesn't matter about your path. It just draws a straight line from your starting point to your ending point, no matter what object comes in between, no matter how much you have moved. Even though if I move around these mountains, the distance that will covered is basically the pink line, that is the magnitude that I've covered. However, displacement is not about that. Displacement is my starting point, which is A, my ending point B, a straight line, that is the gap between that. Is this part clear? So that is what displacement is all about. Now this, unlike this thing, is a vector quantity. Now vector quantity basically is not just magnitude. You see, magnitude is measuring something. Like if I say 5 kilometers, so 5 kilometers is a quantity, which means magnitude. Your scalar quantity just has magnitude. Now if I say someone that I walked for 4 kilometers, they understand that, yeah, 4 kilometers, 4 is the magnitude, 4 kilometers. If I say someone that the bike traveled at around, traveled for 10 kilometers, so 10 kilometer becomes the magnitude. It is the value, it is the numeric value that we can use. But vector, okay, it also has the magnitude, but along with that it has direction. So it has magnitude and direction. Now to understand direction, okay, let's understand what they have done in terms to understand direction right over there. They've given a short this thing that we're going to talk about later, but let's understand what direction basically means over here. You see, direction in simpler words, okay, means something like this. Suppose there's one point A and there's another point B, and from A to B we have a straight line right over here, and you're traveling on this straight line. Suppose there's a vehicle, there's a person who's walking on this line. The length of this entire path, I will say the length of this entire path, okay, is supposedly, I would say, 20 meter. Okay, the person travels from A to B and then B to A. If I ask you to measure the distance that this guy has covered, now the distance basically will be simple. Distance will be the amount of magnitude. It does not have direction. By direction I mean, we won't say ki, it is going forward, that means it is going north. No, it does not have any direction. We're just gonna say that he moved 20 meters from A to B and B to A, it moved 20 meters. So I would say it is AB plus BA, both basically the length of AB is 20 meter, the length of BA is also 20 meter, so that basically gives you 40 meter. So the distance, that is the magnitude covered by this person, is 40 meter. However, pay attention to this now. However, if I look at it in the point, like, physics talks about displacement more. And if I look at it with the point, with keeping displacement as the idea in my head, I understand one thing, that going from A to B, this person is first moving in the directions, towards the B, and then is moving away from B. When I say vector quantities, for now, just understanding that, we will be denoting the forward and backward motion only. When I say vector, yes, it has magnitude, but direction does not mean north, south, east or west. It simply means forward or backward. And the best way to denote forward and backward is by using positive and negative signs. That is what you all are gonna do again. Okay. So when this person is moving from A to B, let's say that he is moving forward. We could say it is positive. Let's say it's positive. So he's moving ahead. That means he is covering the distance positive direction, that is going ahead. And let's say when he comes back, it's negative. It's negative. So once he comes back, it's negative. Now, if you want to catch displacement based on this, it is very easy to understand. You see, displacement can be given by AB, which is positive already, as you guys can see, it is moving in this direction, right? As you guys can see, it's moving in this direction, it's AB. Plus, I'll add the other displacements. However, the other displacement is coming backwards. That means it is negatively denoted, which is in this direction, right? So it's negative. So you will write over here minus BA. Why minus BA? Because it is in the opposite direction. Yes, the motion is in opposite direction, and displacement is a vector quantity which talks about direction, and in physics we denote direction by positive and negative for now. So let's continue ahead. So I have AB, which is 20, plus I have BA. Now remember, it is minus 20. Now you all tell me, sir, minus 20, how can distance be measured in minus? Distance is a quantity which is always measured in positive. You cannot have minus. Height किसी की minus नहीं हो सकती. You cannot measure distance in negative. Let me repeat to you once again. Okay, the signs that we use in physics or studying motion and all that, the sign just basically denotes the direction. It has nothing to do with the quantity. Yes, it comes with the quantity, but nothing to do with the quantity. Minus 20 does not mean minus. You cannot measure anything minus. That's simple. The minus 20 sign, the minus denotes it's measured in opposite direction. That's all. So plus 20 means measuring it from A to B, and minus 20 is from B to A. So plus and minus 20, obviously plus minus becomes minus 20 minus 20 means 0. Now in the eyes of physics, they are right. You see, displacement is the position from your initial moving point to your final moving point. That means you started at A and you end at A. How much have you displaced? How much have you moved from your original position when this experiment started? You have moved nowhere. Even though you have gone 20 meters and come back 20 meters, you have covered a distance, you have covered a magnitude, that is your mehnat. Okay, but when I say displacement, the word displacement itself means how much you have moved from your original position. The displacement is 0 right over there. Forward 20, backward 20, again to its original position. Is this part clear? I hope this part is clear. Okay, so 0 meter is the displacement right over here. This is what we need to understand, the difference between distance and displacement. Distance can be covered by anyone. Okay, even if you come back to the original position, you go back, you go anywhere, doesn't matter. Okay, but displacement matters. Okay, how much you move from your original to your final position. That is what we're going to look on to over here. Okay, let us answer a few questions since we have started this chapter. I hope the idea of distance and displacement is clear to you all. In which of the following examples can you sense motion? How will you explain presence and absence of motion? Yeah, obviously we know that now, right? The motion is when an object changes position. It moves from one position to another. So basically, where do you sense motion? So yeah, the flight of a bird, absolutely, you can see a bird flying. How do you know it's in motion? Yes, it changes its position. You can see it, first the bird was here, now it's here. Yeah, absolutely, it has changed its position. A stationary train. The word stationary means that it is at rest. The train is standing, it's not moving. That means it is not in motion. Leaves flying through air. Yes, obviously, leaves flying right over there, changing its position once again. And a stone lying on a hill. A stone just sitting there in one position does not mean it is in motion. Simply you know it right over there. No change in position means no motion. Now yeah, we see motion in everyday life. Sometimes we cannot accept. Yeah, that's true. And that is what it is. Now let's talk about this. You are traveling in a bus and is the person sitting next to you in motion? Now let's understand this, okay? This topic is something which you're going to put more emphasis on, okay, when you go in higher standards. This question right away. It's something which is called, what do you call it? It puts a paradox. Okay, you're sitting with someone. Suppose you're coming home from school. You're sitting in a bus with your friend, and the bus is moving, obviously. And you are obviously moving with the bus. But everything, your friend next to you, is at rest. That means that person is moving with you, and it is not in motion for you. But in reality, for the world outside, the bus is in motion. You and your friend both sitting are in motion. So that basically means for you, your friend is not in motion because you and your friend are already in motion together. Okay, and but the reality is for someone who's standing outside, you all both are in motion. So yeah, that is what they have mentioned right away. It's a question just to challenge your mental thinking and to understand this. You will study about it more and more as we move ahead. Why do you take into consideration to decide if an object is moving or not? What do you take into consideration? Yes, we take position, right? Changing of position. Has it displaced? Displacement means changing its original position, final position, from one position to another position. Okay, let's understand this, okay? They're asking measure the distance between the points A and B as different shown in the figure, okay? And now measure the distance along the dotted line. Now you can take a scale and do that, but you can obviously look over there. A and B, straight line drawn, you can keep a scale, right? Suppose A is the initial point, B is the final point, right? The person moves, goes round and round. This either you take this path or either you take this path, doesn't matter. But the distance that you cover, the magnitude that you put is right over there. But let's talk about the displacement. It's this direct dotted line from initial to the final position, and that's as simple as it is. Okay, let's see what questions they have for us. Dotted line, which distance is correct according to you? Obviously, all these three are correct, but what matters is what distance you take. Now AB is straight. Anyone would want to go travel straight. That's why it's correct. But let's understand more and let's see what they're saying. Now look at the B part, the second diagram, B1. Sheetal and Prashant's house, and then we have Sangeeta and the school, right? Now obviously you can see Sheetal has a friend called Sangeeta. Okay, with her she goes. Sheetal first went to a friend Sangeeta's house on her way to school, as you guys can see. So she traveled a path traveling 500 meter, and then she again takes 1200 meter of distance, covers 1200 meter of distance with her friend Sangeeta. They both go to school together. Similarly, you can see Prashant went straight. Prashant obviously has no friend, poor guy. Travels straight, goes to the school. Both are walking with the same speed. How will less time take to reach the school? In the above example, if there's any difference in the actual distance. Now let's talk about this. 1300 meter comparatively to the path taken. Now, if I draw something, okay, let's draw and let's understand what this is all about. Suppose I say that start at point A and they are supposed to end at B. Give me a moment. Cut. They start at point A, they end at B. This becomes A, B. Prashant travels straight. That means he displaced basically. He started from initial to final point. So distance and displacement is same. Now distance and displacement are same when the path is traveled in a straight line. That means when you're moving from point A to B, okay, and you cover a distance of about 10 meter, then your displacement, which is denoted by letter S, always remember displacement is denoted by S, is also 10 meter. Why? Because you have taken the shortest path. You have taken the shortest path moving from A to B, and you have not come back or you have not gone ahead or whatever. Okay, distance and displacement is same, and also you have not changed your direction. Simple. Okay, so obviously you can see he has displaced 1300 meter right there, given over there. No issues whatsoever. Let's look at Sangeeta. Now Sangeeta, no, sorry, Sheetal. So Sheetal takes a path like this and goes up like this. Now she was supposed to travel straight A to B, but because she has taken more, obviously she has gone to a friend's house, the total distance that she has covered, she is covering distance. No, this is not displacement, because the initial starting point is A, the final point is B. And this is not the displacement, as you guys can see. Displacement is straight from A to B, 1300 meters. She traveled 500 meters first, and then she traveled plus adding up 1200 meter. That totally gives you 1700 meter, which is more than the displacement. As you guys can see, displacement is just 1300 meter. So obviously she has taken more time because she has covered more distance. You get my point? And yeah, that is what they've said. What is the difference? This brings us to the definition. We're going to mark this. It's very important. Distance is the length of the actual path traveled by an object in motion while going from one point to another. So it is the actual path traveled. As I told you, it is the magnitude. Yes, I have written it is the magnitude. Does not mean that is the proper definition. You have to stick to the definition which is given in your textbook. I repeat it once again. Please stick to the definition given into your textbook. It's the length of the actual path. You measure the actual path you have taken. Doesn't matter where you go, left, right, forward, behind. Doesn't matter. What matters is the actual path that you have taken, that as they have mentioned there, right over there. Whereas let's talk about displacement now. You see, displacement on the other hand, it is the minimum distance, as you guys can see right over there, right, from starting to the finishing point. Okay, as this being the introduction lecture, okay, I'll basically stop away. For any questions, you all can drop down in the comment sections below, and we'll reach to you shortly. Okay, next time we'll be moving up with understanding what this was, just the basics of understanding what motion is all about, what is distance and displacement. Okay, and next time we'll be studying more into motion. We'll be studying what is speed, velocity, and whatnot. Thank you for watching. Take care. Bye.